Hey everyone, welcome to this explainer, brought to you by Forge College. So if you caught our previous lesson on the overview of Solana toolchain integration, you already know that checking our work locally is an absolutely vital step in Web3 development. But today we're going to discover how to take that concept and build a highly effective automated filter. We're talking about keeping messy, broken builds completely out of our repository history. Okay, let's dive right into our engineering schematic for the day. We're going to cover 1. Meeting your repo's bouncer. 2. The branch strategy blueprint. 3. Building the pre-commit hook. 4. Testing your validation gate. 5. Sharing those hooks with teams. And finally, 6. Moving from local to CI. Section 1. Meet your repo's bouncer. So here's the problem. Without a bouncer at the door of your repository, rowdy, broken code, syntax errors, and formatting issues will absolutely crash your Git history party. And honestly, by the time they hit your continuous integration pipeline downstream, it's total chaos. Enter the pre-commit hook. It's essentially a lightweight shell script executed by Git right before a commit goes through. We're basically hiring a tireless, automated bouncer that works seamlessly across macOS, Linux, and Windows to provide immediate check-before-commit semantics. It blocks any bad artifacts from getting inside. Section 2. Branch Strategy Blueprint. Now, this brilliantly illustrates our strategy, because a bouncer is really only as good as the instructions they're given, right? We need a rulebook. Notice how different branches require entirely different levels of security. On your feature branches, well, the bouncer is a bit lenient. A non-blocking option is totally fine while you're just kind of experimenting. But once we move code to the develop branch, passing is strictly required. For release branches, total lockdown, requiring deterministic builds. And finally, on main, local hooks are definitely recommended, but your CI pipeline is the ultimate protected source of truth. Basically, feature branches let you play, but main branches protect the kingdom. Section 3. Building the pre-commit hook. Now, what's really interesting here is how simple the mechanics actually are when we construct this bouncer step by step. First, you're going to need a .git/hooks directory. Next, write a bash script for your validation, like /scripts/toolchain-check.sh. And absolutely crucial here, make it accessible using chmod +x. But here is the really brilliant part. We don't just blindly run a command. We dynamically resolve the repository root, and most importantly, we capture the exact exit status of our toolchain. So if the check fails, our script spits back that exact same error code, slamming the door shut on the commit. Actually, scratch that. We can even make this a bit smarter by giving our bouncer a highly specific VIP list. By using a command like git diff --cached --name-only, we grab exactly what is staged. Then we tell the hook to run validation only when specific files, like your Solana programs, are modified. Rather than checking the whole shebang every single time, it only checks the files actively trying to enter the club. It's a massive time saver for your local processing. Section 4. Testing your validation gate. All right, let's see this thing in action. On the left, pure satisfaction. Check passed, exit code 0, and your readme commit glides right on through. On the right, you break a rule, the check fails with a non-zero exit code, and the commit is instantly aborted. It's just a beautiful protective block. Now, a friendly warning for you. At 5 p.m. on a Friday, when you just want to log off and go home, you are going to be deeply tempted to bypass this using the git commit --no-verify flag. Resist that urge. Bypassing your own bouncer entirely defeats the purpose of having an enforcement mechanism in the first place. Section 5. Sharing hooks with teams. So, a local bouncer is fantastic for a solo project, but how in the world do we scale this to an entire organization? Well, by default, Git hooks live in the .git directory, which is intentionally a hidden folder that isn't version controlled. To fix this, you've got two great options. You can write a quick installer script to copy your hooks over when a new developer clones the repo. Or, and this is even better, use git config core.hooksPath to point Git directly to a versioned folder in your repository. It's literally like handing out the exact same standardized rulebook to everyone on the team, making onboarding completely predictable. Section 6. From local to CI. Let's move to how this all builds into the broader architecture. This right here is the payoff. Before handing off code to your continuous integration pipelines, you want to verify this punch list. Your hook must be executable and run silently when valid. Manual execution should return the correct exit codes. Broken commits must fail immediately, and valid commits should show up perfectly in your Git log.
When you lock this down locally, your CI server downstream gets a massively higher signal-to-noise ratio. You end up solving real architectural problems instead of arguing about syntax errors.
So, the crucial point here is that this predictable local workflow sets up the absolute perfect foundation for automating your CI and CD pipelines. You've built the gate, trained the bouncer, and handed out the rulebook to the entire team. But ask yourself, if your local environment is this strictly locked down, what happens when you unleash these exact same verification rules on a globally distributed cloud server? Well, that's where the real magic of automation happens. Thank you so much for joining me for this explainer. To explore way more of these amazing Web3 resources, be sure to check out forge.college. Keep your repositories clean, and I'll see you next time.